Hello, this is about a numerical which people are not able to catch in the determinant formulas and applications, which corresponds to the LU decomposition or LDU decomposition. We take two examples here and see how it can be done. And for that, we need to use this, total formulas, and we'll see how we can do that. LU decomposition, we will do it first, and then this will break it down into this form. So what is it we do over here? With an example, we'll try to explain that. So here you have a matrix 2, -1, 0, -1, 2, -1. So how do we do the LU decomposition, which might be part of the LDU decomposition? So here we want somehow this value to be equal to 0. For this value to be equal to 0, we need to multiply the what you call the R1 with half and add it to the R2 itself. R2 should be added with the multiplication of R1 with half, and that is what we have written over here. And then we will get here a 0, -1 plus half into 2 will become 0. 2 minus of what you call 1 into half will become 3/2. Then -1 multiplied by 0 into half will become -1. Now, because this is already 0 over here, because already this is 0 here, there is nothing to be done here. So therefore, we'll leave it as it is. Then next is, so we have got a pivot over here, which is 2. Next, we need to make this as pivot. For that to make it as pivot, what we need to do is, we should somehow convert this to the value 0. So to convert this value to 0, naturally, again, what we need to do is multiply this by 2/3 and add to it. So R3 plus 2/3 R2 will go into R3, and that will make naturally, -1 into -1 plus 3/2 into 2/3. That will give us the value equal to 0, and hence we are writing 0 here. And then 2 plus of 2/3 into -1 will give us the value which is 4/3. So once having got this value of the decomposition, this just means that we have done the whole process is nothing but this. 2 -1 0 -1 2 -1, the original matrix, that is equal to question mark into whatever result we have got. So what is this matrix is what we want to get, and that is nothing but we have done this should be just diagonal element should be 1 on 1. The upper part of the triangle is 0. Okay, we want the lower triangulation rather. So this is 0, and this is minus half that is got from the value which is over here. So whatever, this should be minus of minus half, subtraction is to be considered, so that minus half is transferred there. Similarly, this 2/3 plus 2/3 is there, minus of minus 2/3, therefore minus will be transferred to minus 2/3. And this is 0 because we have not changed that anyway, because this value is 0. There is no, so to say, decomposition here. Hence, we are keeping it as it is. That's why it remains 0. So having written this, the what you call L as this, that is whatever we had is was A, and this is L, and this is what is that, U. And once having the U value over here, now what we can do is this U can be further reduced. So this U can be written as only the diagonal matrix 2, 3/2, 4/3, this as it is. And then if I multiply something, then I should, to the diagonal matrix, somehow I should get this, so that we'll have a LDU. So to get that, it is but natural that we need to use the formula which is written over here. Okay, here. So you have here in the U, we have U12, and that should be divided by D1. You have U13 in the U, that should be divided by D1. So all row 1 elements should be divided by D1, leaving the, only the upper, uh, so to say, triangular entries, upper triangular entries. The second row element should be divided by D2. Third row element should be divided by D3. Only the upper triangular elements above the diagonal. So to do that, we will again write it over here. So that means I need a, minus half over here. So this quantity should be, minus 1 by 2. This divided by this. Then this divided by this will give me 0 only. That is why it is 0 here. Then this divided by this value. Minus 1 divided by 2 by 3 will give me 3 by 2. Minus 1 divided by 3 by 2 will give me minus 2 by 3 here. Okay. So that's the way we can find, and that solves the problem. Let us take one more example, which is 0, 1, 1, 1, 1, 0, 1, 2, 3, 4. Now this we will call it as the LDU decomposition with PA, with the, so to say, permutation also. Okay, with the permutation also. Now permutation is there because of the row exchange. Row exchange is to be done only when the pivot should not be 0. So pivot should not be 0. Because the pivot is 0 over here, we just exchange the first and second rows, which is same as the permutation. So if you want to do the permutation, it is equivalent to multiplying with by a, permutation matrix, which is something like this for exchanging the first and second row. So this quantity is nothing but this multiplied by the permuted matrix, that is rows 1 and 2 exchange. That's the standard format. So if you want to exchange, then in the I matrix, whatever was there, you just have to, transfer the two rows values in the I identity matrix. Then we will get the corresponding multiplication like this. You can check it by multiplying this with this matrix with this, so that we'll get this value. So having got that, now this A has to be decomposed into LDU. For that, we write over here 1, 0, 0, 0, 1, 1, 2, 3, 4. Now this 0 is already 0, so there is nothing to be done. It will remain there itself. But now in place of this 2, I should have a 0. For that to be a 0, I should now multiply this by minus 2 and subtract from this. R3 minus 2 R1 should go into R3 itself. So at that time, we will get a 0 here. 3 minus of 2 into 0 will give me 3. 4 into minus of 2 into 1 will give me 2. So I have got this term here. Now next what I need to do is I should make this 0. To make this 0, again I should multiply this by minus 3 and add it to this row and substitute it in the R3 itself. So R3 is R3 minus 3R2. So that will be 0 minus 3, 0 will be 0 only. 3 minus 3 into 1 will be 0 again. Then 2 minus 3 into 1 will be minus 1. Okay. So having got this, this is nothing but, you can write that as, again, this question mark equal to this. Or rather, how did we get this? What is the matrix which will transform from here to here? What is the matrix which will transform from here to here? That is what we are trying to write. And that turns out to be the matrix which is something like this. 1, 0, 0, 0, 1, 0, 2, 3, 1. Now this 2 is coming directly again from here. Minus should not be considered. 2 is to be considered. in place of -3, we'll get that 3 over here. Diagonal elements remaining 1, 1, 1. So once we are finished with this, then again we need to do the transformation of u into L dv or might be du again. So to get that, again we need to use the same formula here: u12 by d1, u13 by d1, u23 by d2, and so on. So that just means that to get this matrix, okay. And so what we need to do is this: I should divide by 1, I'll get 0 only. This I should divide by 1, I'll get 1 itself. This I should divide by 1, I'll get that itself. And the rest of the thing remains same. So it doesn't make any difference. Again, you'll get the same thing, only that here you have 1, 0, 0, 0, 1, 0, 0, 0, minus 1. This is D, and this is either you can call it as V or U. So this finishes the example. This is what we tried to do in the decomposition, which corresponds to the problem over here. Here, it's the same thing. Whatever is done there, same thing is done here also. Similarly, the process is just this. So first part is LU decomposition. Second part is the factorization of U into D and the upper triangular matrix, which should have been really U, but we write it like that. And P refers to just the permutation which is needed. So using that only, all these are done. So one can try all these examples: A here, this A here, this A here, and definitely we are going to get this or this or this, whatever it is, by means of LDU decomposition. Thank you.